Hey everyone, in this video we are going to see how we can develop a machine learning model on AWS Sagemaker and how we can integrate it with AWS Lambda and API Gateway. So first log into your AWS console. Type in your email address and the password and click on sign in. In the search bar, you can search for SageMaker and click on Amazon SageMaker. Okay, so we are in the Amazon SageMaker console. Just go down and click on Notebooks and click on Notebook Instances. I have already created a notebook instance, but you can start by creating one. Click on the Create Notebook Instance. And here you can give the notebook instance name. It is a user-defined name. You can specify anything you want, maybe just type and test. And this is the notebook instance type. We can see like several different instance types here if you click on the drop down. So these are optimized to fit different use cases. All these instances comprise variant combination of CPU, memory, storage, and networking capacity. So I'm going to just select this T3 medium for my demo. So this provides 2 CPU cores, 4 GB of memory, and 5 Gbps network performance. And moving on, going to Elastic Inference, we can use this if we are developing the deep learning model. So these are basically GPU instances, which we can add in addition to our CPU instance. So platform identifier, it's basically an operating system. So different kernels are available based on the platform we select. So I'm just selecting Amazon Linux 2 and Jupyter Lab 3. And click on additional configuration. We can see lifecycle configuration here. We can use this option when we want to run the shell scripts when we create notebook instance or whenever we start one. And volume size, this is the storage volume for our notebook instance. We can increase it up to 16 terabytes. And the other option is minimum IMDS version, or it is instance metadata service version. I'm selecting version 2 here. It provides additional layer of security to access our instance metadata. And scroll down. We have to create IAM role when you're creating a notebook instance. So if you click on the drop down, you can see several different options. Like one is creating a new role, another one is enter a customized IAM role ARN, or use an existing role. So I have already created a SageMaker IAM role. So I'm going to use this one. If you are going to create it for the first time, you can click on Create New Role, and you create new role, and you can see this pop-up. You can click on any S3 bucket, which gives this IAM role access to any S3 bucket, or you can specify S3 bucket if you want to specify a particular S3 bucket, and you can specify none. And by default, this IAM role will have access to certain S3 buckets. So which consists any S3 bucket with S3 SageMaker in the name, and any S3 object with SageMaker in the name, any S3 object with a tag SageMaker and the value true, and any S3 bucket with a bucket policy allowing access to SageMaker. So by default, an IAM role that we created for the SageMaker notebook instance will have access to the SageMaker objects on the S3 bucket, which are following in these categories. So you can just click on the create role here to create a role. For my demo, I have specified any S3 bucket and I have created the role for my notebook. So I'm not going to create anything here. I'm going to use whatever I have already created. And this encryption key option. So if you want to encrypt the notebook data, you can use this option. For this, you need a KMS key. So for now, I'm just leaving it as this. So we have several different optional options available here. If you click on the network, and we can see this VPC option. If you want to connect to the VPC, we can use this option. And if you want to connect to a Git repository for your work, then you can use this option. And if you want to enable the tags, you can use this option. And once you fill in all this information, you can create notebook instance. I have already created a notebook instance, so I'm just canceling this option. So once you create the notebook, you can see a notebook that you created with its name appearing here, and the instance type and the creation type and status should be in service. So when you create a notebook, it will start in a pending status and comes to in service status. So you have to wait until this icon appears to in service, and then this notebook is ready to use. So click on the notebook and then click on the Open Jupyter icon. Now we are entering into Jupyter Notebook. Okay, so I have several different files available here already for my demo purpose. But if you are the first time, then what you have to do is just click on New, and you can open a notebook instance by selecting the kernel. So I'm going to select Conda Python 3 kernel. So once you click this, a new notebook instance will appear. You can rename it here by giving a name. So this will appear here. And if you go to home page, you can see that the new file got created just like seconds before. So I do not want this, so I'll delete it. And you also have to upload the data files into your home. So you can click on upload, and then you can upload it from your local. So I have already created the data folder, and in the data folder I have the new thyroid. This is the data file, and columns underscore name.txt, which has got the column names. So I have created the folder and I have uploaded the files here. And let's go back. So for now, I'll delete this test file. Okay. So I have already had my notebook created, ready for this demo. So I'm opening it. So in this code, what I'm doing is I have imported thyroid dataset from online. Like I showed before, the data folder has got two files. One is the actual dataset, and the other one is the columns. So I am using that to predict the thyroid disorder. So let's go into the code. So first, this block of code right here, I'm importing the required libraries using this code. So OS helps us to work with the directories, and Boto3 helps us to interact with any other AWS services like S3 or EC2. And SageMaker, we needed to build, and train our machine learning models. And I'm also initiating a variable role with SageMaker.getExecution role. This is nothing but the execution role or the IAM role that we have created while creating the notebook instance. And then I'm also initiating another variable called region with boto3.session.region name. This is the region in which our trying job is going to run. So my account is on North Virginia region, so that is what spins up here. So I'm going to initiate another variable called as bucket with sagemaker.session.default bucket. So we can also use an S3 bucket if it exists. Otherwise, we can just leave it with a default bucket. I initiated another variable called prefix with a value SageMaker/thyroid prediction. This is where I'm going to upload my training files within the S3 bucket. And then I have also imported 3 different libraries. One is Pandas. Pandas is used for data analysis and manipulation. And I also imported NumPy. It provides mathematical functions for processing the data. And I also imported Matplotlib. This is a visualization module. And then the next block of code, here I'm initiating S3 variable with Boto3 S3 client. So it basically represents S3 and helps us to access any methods inside S3. So like creating objects or copying objects or any operations on S3. And then moving on, I have initiated SageMaker_session variable with SageMaker.session. So it manages interactions with AWS SageMaker APIs and any other AWS services as needed. And then using this SageMaker session, I'm using this upload data function, and I'm uploading this data into my S3 bucket. So I have specified this data folder. So whatever is there in this data folder, I'm going to upload it into my S3 bucket. So I have specified the S3 bucket as default bucket, which actually means like if there is no bucket, one bucket will be created for the process and data will be uploaded into that. So I have, using this code, I have uploaded data into the S3 bucket, and I'm going to store this output path in the train_output variable. So when I run this, I can see the location of this data. So we can go into the S3 bucket to locate whether the data and the files have been uploaded correctly or not. Just go into the services, and then on the search bar, click S3. We are in Amazon S3, and I can see there's a bucket created. Click on it, and we can see our data folder has been created here. And when we click on it, we can see columns underscore name.txt and new thyroid data has been added into this folder. So we are good with it. And then moving on. So this particular piece of code actually lists out the column values. So I'm reading the columns underscore name.txt file, and I'm putting it into our list, and I'm storing it into a headers variable, and I'm running the headers variable, and then I can see all the headers here. We have 6 columns. One is this is prediction, and T3 Ryzen test is thyroxine, is triiodothyronine, and basal TSH and TSH difference. And this is prediction is the label column for us, which we are going to predict with our model. And then moving on, I also read, with this piece of code, I also read the thyroid data set. So we can see I use pandas for this, and I have stored these values in the data frame. And when I run the data frame, I can see the data here. We can see there are 215 rows and 6 columns, which is fine. And with this piece of code, I have actually I actually created or I actually got the number of the value counts for the disease prediction column. I can see there are 150 rows with a value of 1, and 35 rows with a value of 2, and 30 rows with a value of 3. So for the XGBoost model, we should have labels starting with 0 but not with 1. So this 1 to 3 should change to 0, 1, and 2. So I have used this label encoder from sklearn.preprocessing to pre-process that. So I have used the fit and transform method in this label encoder on top of this disease prediction column on the data frame. And then I have printed out the value counts of the disease prediction. And now I can see 150 rows with a value of 0, and 35 rows with a value of 1, and 30 rows with a value of 2. So which is good for us. And then after I did that, I have used this code to display the first 5 rows from the data frame. And I also use this describe method to describe the data frame. So this basically describes or gives us the descriptive statistics of our data set. What it basically gives is like the count of number of rows in each column. We can see 215 consistently across all the columns, and the mean value, and the standard deviation, and the minimum value, and the value at the 25th percentile, and the 50th percentile, 75th percentile, and the maximum value. So these are the descriptive statistics of the data set. And then moving on, I have divided the data set into X and Y variable. So I have selected all the columns except the disease prediction into X variable, and thus the disease prediction into Y variable. And then from sklearn.model selection, I have imported try and test split to split my data into try and test set. So I have used the try and test split, and I have split my X and Y variables into in the test size of 0.2 and the random state of 1. And then I have stored them into X train, X test, Y train, and Y test. So we have got the training and the test sets now. I'm still going to divide my train set into train and validation set using the same train and test split method, train test split method. So using this method, I have passed in X train and Y train, and I have provided the test size of 0.2, and I have given the random state as 1. So now we have got the train and the validation sets. So in this piece of code, what I'm doing is I'm going to concatenate Y train with X train, and Y val with X val, and Y test with X test, and I'm going to store this in train, validation, and test set. So when I type in or when I run the train, I can see there are 137 rows and 6 columns in the train set. And when I check for the value counts of the disease prediction in the train set, I can see there are 93 rows with a value of 0, and 24 rows with a value of 2, and 20 rows with a value of 1. And when I see the value counts of disease prediction in the validation set, I can see 25 rows with a value of 0, and 8 rows with a value of 1, and 2 rows with a value of 2. And when I see the value counts of disease prediction in the test set, I can see the 32 rows with a value of 0, and 7 rows with a value of 1, and 4 rows with a value of 2. This is fine for our model for this demo. And then now with this piece of code, what I'm doing is I'm going to convert my train, validation, and test sets to CSV format. And I have used this code to do that. And then moving on, we have to upload our train, validation, and test set into SD bucket. We have to upload that into SD bucket so that when we actually run our training job, the model can actually go into the SD bucket where we put in the CSV files, and they can pick up the files from that location, and they can actually train the model. So I have used this piece of code right here to upload my files into the S3 bucket. and then we can list down the files that got uploaded into the S3 bucket. So I have used this piece of code right here, and when I run this, I can see these three values here, which actually means in this location, SageMaker /thyroid prediction /data / the test CSV, Trine CSV, and validation CSV. Let's see whether we have these files available in this location or not. So let's go to S3 bucket, click on the bucket and the SageMaker and thyroid prediction, and go to data. We can see test.csv, trine.csv, and validation.csv. These files have got uploaded into our S3 bucket. So that is good. And then, moving on. So I have also imported rule and rule configs from SageMaker.debugger module. So basically, the SageMaker debugger module provides high-level methods to set up debugger configurations to monitor, profile, and debug the training job. And rule configs helps to configure SageMaker built-in rules built-in rules with rule class method. So that's why we have imported that. And I have also specified the S3 output location. This is the output location, like S3 / bucket name / prefix / XGBoost _model, where I'm going to store my output files. And I have also initiated a variable called container with the image that I'm going to retrieve it from one of the ECR containers. So basically, these ML models are just the Docker images that are located on a ECR container. So we are going to retrieve it, and we are going to store it into a container variable. So we have to use this code to retrieve the image of the XGBoost model that we are going to use it, and we can use this container further in the process to train the model. So I have specified the model, and I have specified the region name and the version. So moving on. So we have to construct a SageMaker estimator with all the parameters that are needed for the XGBoost model to train. So not just the XGBoost model, for any model, we need to construct an estimator. So when we look at this estimator, it takes in all these parameters. So image URI is the container image. That we have retrieved from an ECR container, ECR registry. And the role is the IAM role that we have got or specified while we are creating the notebook instance. And we have to specify the instance count, instance type, and volume size. This is the EC2 instance that we are specifying for the estimator. So this uses that particular instance while the model starts to train. And I have also specified the output path with the S3 output location where the output files will be uploaded while the model gets trained. And we have also initiated SageMaker session, which is needed to interact with other AWS services. And we have also specified the rules to configure or to generate the XGBoost report. So this is how we construct the estimator. And we also have to specify the hyperparameters that are required for the model. For XGBoost model, I have specified certain parameters, and for different models, we have to specify different hyperparameters specific to that model. And for XGBoost model, there are several different types of hyperparameters that are available, but I'm just specifying only that's needed for this demo. So since I have 3 different classes in my data set, so I have specified number of classes equals to 3 and number of rounds equals to 100. What it basically does, it actually iterates 100 different times during the training process to give out a better model. And the objective, I have specified it as a multi-softmax. And then moving on, I have also imported training input from SageMaker.session. Basically, what it does is it takes in the locations of the train and the validation sets, which we can use further in the training process to fit our data. So in this training input, I have specified the location of the train.csv file, and I have stored it into a train_input variable. And I have also specified validation.csv file location in the S3 bucket, and I have specified it in the validation_input variable. So now we are ready to fit our model. So I have used this fit method, and I have fit the train input and the validation input into this model, and I have run this particular piece of code. And then it started training, and it runs until 100 times, or it iterates until 100 times. And we can see the training job got completed, and we can also see the training seconds and the billable seconds here. Once I have the model trained, or during the process of training, there are several different files that get created, or the training reports that gets created. And these are present in the S3 bucket. So right here, if we see, so this particular piece of code got the S3 bucket URL where the debugger training reports are generated, and it lists out all the reports. So when we run this code, we can see all the reports here. And then moving on with this code, we are downloading the XGBoost training and profiling report to our current workspace. So I have downloaded all these reports into my current workspace, and then with this piece of code, we actually getting a link. Basically, it returns a file link of the debugger profiling report. So when we click on this link, we can see the summaries and the details of EC2 instance, resource utilization, system bottleneck detection, and Python operation profiling results here. So we can just go into the details of what this report provides. And then moving on here, if we run this piece of code, we can see we can get the location of the S3 bucket where our model is located after the training. So this is located in this location, so we can just directly go into our S3 bucket to locate this model. So it is located in Sagemaker /thyroid prediction /XGBoost model / this location. So I'll just go here. Sagemaker /thyroid prediction and then XGBoost model. And I will open one that is recent. Okay, so I have run it like several different times. So this is so one that is recent is what I'm trying to open on the S3 bucket, but whatever I can see here is from 27th, 12/27. So we can open even 12/27 to see whether there are the files that got created or not. So I'll just open December 27th, and I can open this output folder, and I can see the model got created. So even on December 30th, I have run this model again, so I can still see the model here. Okay, then moving on, now we are ready with our model, and we have to deploy it to a SageMaker endpoint, which we can use it further down the process to get the real-time predictions. So I already imported the SageMaker, so I can just comment it out. And so from SageMaker.serializers, I have imported CSV serializer. And then I have used this deploy method to deploy my XGBoost model onto our endpoint. So I have given all the required parameters here, the instance count and the instance type, and I have also specified the CSV serializer here. And then moving on, so it will take a little bit of time to deploy it to the endpoint. So once we see this kind of output, it actually means the model got deployed onto an endpoint. So we can get the endpoint name by typing in this code, and we can see this is the endpoint name, which we have to use further down in the process to invoke this endpoint. Let's evaluate this model. So this particular function actually takes in around 500 rows at a time, and it actually gives the predictions on top of the model. So I have used this XGB_predictor .predict method, and I am passing in the data into this, and I am returning the results. So this particular function actually takes in the data, and it returns out the result. So I have used this predict function, and I have passed in the data from the test data set, like all the data except the label, and then I have stored the results into the predictions variable. So when we run the predictions variable, we can see all the the predictions in an array. So we can see how our model is performing by comparing these predictions with the actual values. So from sklearn.metrics, I have imported confusion matrix, accuracy score, and the classification report. And I have taken the actual values into y-test from the test dataset and the predictions into y-pred. And I have created the confusion matrix with the y-test and y-pred, and the accuracy score with y-test and y-pred, and the classification report with y-test and y-pred. So we can see the classification report here, and we can see the accuracy here, accuracy score of 97.6, which is good. And we can also see the classification report here, the precision, recall, and the F1 scores. And with this accuracy, this is how we evaluate the model. And with this accuracy, we can define with our model, or otherwise we can just go further one step and create a function which actually gives out the error rate and the confusion matrix, and we can use that values to represent that in a graphical format. So I have I have built this function to return out the error rate and the confusion matrix, which takes in the predictions and the labels, uh, which are the predictions and the actual values. So I have used this function. In this code right here, so this error rate function right here, it has or I have passed in ypred and ytest values into here, and I have stored the results into test error and confusions, and I have used this to plot my confusion matrix and represent it into a graphical format here with this particular chunk of code. So I can see the test error rate of 0.3% and the confusion matrix we can see here, which is what we have already seen, but this is just a different way of representing. So let's see how we can predict it in the real time. Like this is just a test here. We can we can use the Lambda functions, and we can use the API gateway to do the real-time predictions. So I have used the test set, and I have got using this head function. I have got the first 5 rows. I have taken the first row data, and I have put that into a predict method from the XGB underscore predict model, which we have created. I have used the predict method and put in the data, and I see the result here as 0, which is exactly correct. What is appearing in the what is the actual value? And then I also took another row, which is 112, 2.6, 0.7, 41. .0 and 19.0, and I have taken those values, and I have predicted the value, which is 2, which is correct with the test data set. So which is fine, this is fine to go ahead and build our Lambda function. So let's go and see how we can build a Lambda function and invoke this endpoint and do our real-time predictions. And before we go to Lambda functions, let's see how the endpoint is created on the Sagemaker console. So on the search bar, type in Sagemaker. So click on Amazon Sagemaker. And go to Inference and click on Endpoints. We can see the endpoint here. This is the endpoint name which we are going to use in our Lambda function. So this is how an endpoint will appear on the Sagemaker console. So we can just use this endpoint. I have already created a Lambda function which I can show you. So on the search bar, search for Lambda. And click on Lambda. Okay. So basically, AWS Lambda is a serverless event-driven compute service that lets us code for any applications without having to manage the servers. So once you enter into AWS Lambda console, we can see it this way. And yeah, so I have already created the function, but you can start creating one by clicking on Create Function. So you have 3 different options on how you can create a function. You can create a function from scratch, or you can use a blueprint that is already available and you can develop on that, or you can retrieve a container image to develop the function. And under the function name, you can specify the function name, and the runtime is nothing but in which programming language that you want to run this function. So I'm going to use Python 3.9, and now moving on to permissions. You have to create an execution role or the IAM role for while you are creating the Lambda function. Just like how we created IAM role for our notebook instance, we have to create IAM role for the Lambda function. So we got the same different options, just like how we saw on the notebook while creating the notebook instance. Same here, you can create a new role or use an existing role or create a new role from AWS policy templates. For the demo or for practice, you can just click on the create new role. So it will create a new role, and in the advanced settings, you can these are options, like if you can enable the code signing if you want to. So basically, when we check this option, Lambda checks every code deployment and verifies that the code package is signed by a trusted source. And if we enable this function URL, and URL will be created for this function, which we can use to invoke this function through HTTP endpoints via a web browser. And when we enable the tags, we can actually tag Lambda functions to activate attribute-based access control. And if you want to use the VPC connection, you can enable this VPC. So that's all. So you can click on create function. So I'm just canceling it because I have already created a function, so I can directly click on it. So once you create the function, you will see it in this way. So I can click directly on the function. So my function is loading now. So this is how the Lambda function looks like. In the first section, I have imported all the required libraries. All these libraries we have seen while we are in our notebook instance while we are developing our code or developing our machine learning model. So there is one extra thing here that I have imported JSON to work with the JSON data. So I have created an endpoint underscore name variable with the endpoint name. That this is the SageMaker endpoint that got created. That is the name that I have put in here. And I have also used the SageMaker runtime service using Boto client, and I have specified that into a runtime variable. And then moving on, this is the actual function that actually takes in the input data and results out the response. So, and in this function, there are two parameters, and event is where or what takes the input parameters or the input data, and here it prints out the input data, and then this particular piece of code actually parses the JSON data or the string data that I have that we are going to pass into this function, and it is going to store it into a data variable. And from the data variable, I am going to read the data from the key data. So this is like a key value pair. So I'm going to specify my string in a key called data. So this is so this variable payload actually takes in the data from the key called data, and then it prints out the data or the string that I am going to pass in. So, and then I'm going to invoke the endpoint using runtime.invoke endpoint method, and it takes in certain parameters like endpoint name, content type, and the body. So endpoint name is the endpoint where we created our endpoint name is nothing but the endpoint of the SageMaker ML model that we have just deployed. That's the endpoint name, and content type is text or CSV, and the body is the payload where we have passed our data, and this is the variable that we are going to use in the body part. And then once we run this particular chunk of code, we get a response, and we are going to print this response here. So once you have this code set up, you can configure a test event. Click on the configure test event, and you can create a new event by clicking here, or you can edit a saved event. So I have already created a new event with this data here. So click on the create new event, and give an event name, maybe event 3. So set it as private. You do not have to bother about this one. Event 3, and that's all. We can still use the same code I already used for the two other different events I have created, or you can specify different values here. It doesn't matter, like whatever you do, how many events you create or whatever is done here. So click on cancel or click on save while you're creating for the first time. I already have the events created, so I'm not creating it again. So I'm just clicking on cancel. So once you have created your event or configured your test event, you can click on that event. If you created multiple, if it is just one, that will be set by default, and then you can click on the test. So okay, so for my event 1, the response is 0. So basically for this data points, I got the prediction response as 0, and then I also I can also just click on event 2, and then I can click on test. So okay, so with this data points, I can see the responses too. So it is good that Lambda function is performing the way we want it, but let's integrate it with the API and then see how we can do the real-time predictions. So one important thing in this Lambda function is when you created a Lambda function, you have to give the Lambda, you have to give the role that that got created, the AWS SageMaker access, so that it can interact with the SageMaker endpoint. Otherwise, it cannot interact with AWS SageMaker. So you can go on the search bar, you can type IAM, and you can click on IAM. So this is the IAM management console. When you click on the roles, you can see all the roles that are available here. So this is the Lambda function that got created while I created the thyroid prediction function. You can click on this. I have already added the SageMaker full access, but when you create it for the first time, you can just go and click on add permissions, and you can go and click on attach policies, and then you can add the SageMaker full access here and type in SageMaker, and you will get the SageMaker full access, and you can attach it here. Since I have already attached, I'm not doing anything here, so I can cancel it. So this is important for your Lambda function to interact with the SageMaker. So once you're good with that, you can just go to API gateway, click on API or type API. We can get this API gateway service, click on it. So this is the API gateway service. When you enter into this, you can click on APIs. And I have already created my API, but I'm going to create it again because this is a very quick process, so I can just show it directly. So click on Create API, and we have the several different options that you can see here, and we are going to use REST API, and click on Build. So we have different options here, and I'm going to leave it as this. And since this is a new API, I'm just leaving this option as this. And under the API name, I'm just giving some. This is a user-defined name. I just gave like th_prediction, and I'm going to create. I'm going to click on Create API. And in the actions, we have to click on Create Method, and the method we are going to create is a post method. Click on Post and click on this check mark, and the post method is going to create. So click on this one once it got created, and we are going to integrate our API with the Lambda function. So that's the integration type, and everything else leave as is. And the Lambda function, just type in T, and it just shows you what all functions that are available on the Lambda side. So I'm going to click this thyroid prediction function, and then click Save, and click OK. Okay, so once you have done this, you have to deploy this API. Click on Deploy API, and click on Deploy Stage. I can create a new stage here, and the stage name would be, let's say, Test, and click on Deploy. So yeah, right now we have this URL available. We have deployed our API, and we can use this URL to get the real-time predictions from our SageMaker endpoint. Just copy this URL. You can use this URL at any place in different applications to get the real-time predictions. So for now, to test this, I'm going to use the Postman. I have already downloaded it. If you do not have, you can download it from Google. Sorry. Okay, so open the Postman app. Sorry, it's taking a while. So you can click on, you can close all this. So in the post method, you can, so click on the post method and you can type in the URL that we got from the API. And under the body, you have to specify the input data. So I have already, tested it for a different API that I have created already. So I'm going to use the same input data. So once I have this input data put in here under the body, I can click on send. See, we can see the response here as 2. So which is good. The API is working as expected. That the API is interacting with Lambda, which is interacting with the intern interacting with the SageMaker endpoint. So that is how we can integrate AWS SageMaker with Lambda and with the API gateway. Hope this helps you. Thank you so much for watching the video.